Welcome. In this video I'm going to show you how you can perform a post-hoc analysis after a goodness of fit test using goodness of fit test and a residual analysis. And R. So this will not use pairwise. Pairwise would indicate to compare each category with each of the other categories, so every possible pair. Residual, what I intend to mean with that is it will only look at the category versus its expected count and basically all other categories combined as one large category and their expected count. Now I'm using Jupyter Lab with an R kernel, or actually I should select my kernel, but the code should also work in, for example, RStudio. The packages I have pre-installed are the ones that simply come with RStudio, I think. This video will focus, as mentioned, on how to obtain the output, not so much if you should be running this output. It's also possible to use, instead of a goodness of fit test, binary tests. I have separate videos on those as well. Now to show you how this can be done, I need some example data, so I'll load in the general social survey data from 2012, adjusted for some example purposes. I don't actually need all of its data, I just need a nominal field. So I'll be using as a nominal field the marital status, mar1, and to give you a quick impression, a table from that showing the counts, so 79 people indicated to be separated. I actually have my own library. It's not on CRAN, but once you've installed it, it actually has a function that can just do all of this work for you. But if you don't want to use that, you could use also our statics. It's a slightly different library, and it has a function pairwise chi-square goodness of fit test. It needs the counts, so I can put those in, and you can specify which method. You can't really specify which chi-square test it's running, so that seems to be a little bit limited, but you could specify the expected counts. If you have those, it actually wants them as proportions, so we could put those in like this, and then I can add that as an additional parameter. I get the results, and as you can see, these are the observed counts, these are the expected counts. This is the number of categories. It's always comparing to divorced versus all others. If you want to compare each one by one, then that's a pairwise test. The test statistics, which should be a chi-square value, the p-value, but then we're usually more interested in the adjusted one, so this is Bonferroni adjusted, because we're doing multiple tests. And if this value is below a predefined threshold, usually below 0.05, we would speak of a significant result. The e minus 0.8 means I need to divide this 2.27 by 10 to the power of 8, so that's extremely small, so below the 0.05, so significant. This is also significant. This would be 0.09, so that's not significant. 0.07, also not significant. So only these two are significant. That means that their observed count is significantly different from their expected count. If you don't want to use any library, then we could of course first remove all our missing values, then create that frequency table. We can get the different categories by using the names function, and then again I set my expected counts, and then I just have to go over all the simple goodness of fit test, also goodness of fit tests. For example, a Pearson chi-square test. So I take the sum. I have a separate video on how to perform Pearson chi-square test, so this will be very short. I'll go over all the possible categories. Then I take the observed count, the expected count of that category versus the observed count of all other categories, so that's just the total minus the selected category. I then perform the chi-square test with the chi-square test function. I get the chi-square value, the p-value. The adjusted p-value is simply the p-value multiplied with the number of categories. Unless that becomes bigger than 1, then it should just be 1. That's a Bonferroni correction. There are other ways to correct. Print the results, and that should give us all the results that we need and saw earlier also from the statics library function. Alright, I hope this video was somewhat helpful, and thank you for watching.